DNA data storage is an emerging technology that has the potential to revolutionize the way we store and retrieve vast amounts of data. By leveraging the unique properties of DNA molecules, scientists are exploring the possibility of using DNA as a highly efficient and durable medium for long-term data storage. DNA, or deoxyribonucleic acid, is the molecule that contains the genetic instructions for all living organisms. It is composed of 4 nucleotide bases: adenine A, thymine T, cytosine C, and guanine G, arranged in a specific sequence. This sequence of bases encodes the genetic information that determines an organism's traits and functions. One of the key advantages of using DNA for data storage is its incredible storage density. DNA molecules are incredibly compact, with the ability to store vast amounts of information in a very small space. By encoding data into the sequence of nucleotide bases, it is possible to store massive amounts of digital information in a tiny amount of DNA. Furthermore, DNA is also incredibly durable and stable. Under optimal conditions, DNA can remain intact for thousands of years, making it an ideal medium for long-term data storage. This durability is in stark contrast to traditional storage media, such as hard drives or optical discs, which degrade over time and are susceptible to physical damage. The process of encoding data into DNA involves converting digital information into a DNA sequence. This is typically done using a coding scheme that maps binary data, 0s and 1s, to the 4 nucleotide bases. Once the data has been encoded into a DNA sequence, it can be synthesized in the laboratory using biochemical techniques. To retrieve the data stored in DNA, the reverse process is carried out. The DNA sequence is sequenced using high-throughput sequencing technologies, and the original data is reconstructed from the sequence of bases. While this process is currently time-consuming and expensive, advances in DNA sequencing technologies are making it increasingly feasible to retrieve data from DNA storage quickly and cost-effectively. There are several challenges that need to be addressed in order to realize the full potential of DNA data storage. One of the main challenges is the cost of synthesizing and sequencing DNA. While the cost of DNA synthesis and sequencing has been steadily decreasing in recent years, it is still more expensive than traditional data storage methods. Another challenge is the speed of read and write operations. While DNA has the potential to store vast amounts of data, the process of encoding and decoding data into DNA is currently slower than traditional data storage methods. Improvements in biochemical techniques and DNA sequencing technologies are needed to make DNA data storage more practical for everyday use. Despite these challenges, researchers are making significant progress in advancing the field of DNA data storage. Recent studies have demonstrated the feasibility of storing and retrieving large amounts of data in DNA, paving the way for future applications of this technology in areas such as archival storage, long-term data preservation, and data backup. DNA data storage holds great promise as a highly efficient and durable medium for long-term data storage. By leveraging the unique properties of DNA molecules, researchers are exploring new ways to store and retrieve vast amounts of digital information. While there are still challenges to overcome, the potential benefits of DNA data storage make it an exciting area of research with far-reaching implications for the future of data storage technology.